Ada. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam
How are you?
warahmatullahi.
Everybody okay?
Alhamdulillah.
Okay, good. How's the weather? I think now the weather is it's not very wet anymore, right? For the past 2 days, I don't think it was raining. It just cool, but no rain. Very nice weather. Okay, anything from last class? Not last class, the class before last, where we have the discussion on the general power rule of integration. Any problem with that one? Okay, all right, good. Now today I'm going to finish up the first part. Not the first part. I think I'm going to finish up chapter 12 today. And then we move on to the next chapter, chapter number 13. I'm going to discuss initial condition. In other words, we want to find the value of C. So we call it a particular solution. We want to find the value of C given a point. So that point, okay, that point that is given, we call it initial condition. So we can find the value of C. So that constant will be specific. So we call it a particular solution. And then we're going to look at applications. Okay, applications for chapter number 12. So basically the application, what we do, we use the concept of antiderivative. We know the derivative. We want to find the function for which we integrate, we get. Oh no, I'm sorry. We know the derivative. You want to find the function, okay, which you differentiate, you get that. Okay, so let's start. Now, when you look at initial condition, we are doing this. You are given a point, okay, a point, and then you want to find the value of C, the constant for the integration. So let's look at the thing. Okay, let's consider an example. Let's say you have a function, a simple function that you want to integrate. And then you will have the constant. And then you want to find the value of C. So here this is what it is called, the initial condition. In other words, you want to find a specific value of the constant C. Okay, we consider an example. Let's say we have a function y equal to f of x equal to 5x to the power of 3 minus 3. No, minus 3. We already have 3, so we use another number. Minus 9. Now you want to find the integration of the function. So you integrate the function, you got f of x. No, we don't do that because you normally integrate the function. So you integrate f of x. The x, what we get is the integral of 5x cubed minus 9 dx. So integrate that, you will get a C. Okay, you get a C. And that you want to find the value of C. So that's what we call specific condition. So that is equal to what? That is equal to 5 x to the power 4 divided by 4 minus 9x plus c. So that is constant c. Now that c is a general constant. Okay, it's a general constant. It can be any value. So if you want to find a specific value, okay, you want to find a specific value, a constant, a specific value of c. So that where you use the initial condition. All right. So given an initial condition. Now, initial condition basically is a point. Okay. So in other words, you're given a point. So you're given a point on that function. So we call this the integral of the function. We call it f of x. So given a function, or given a value or a point, I'm sorry, not a value, a point, then you find the value of c. So let's say, okay, say at x equal to 5, f of 5 is equal to 20. So that is an initial condition. So we are given a point. So in other words, you're given a point, 5, 20. All right. So now what you do, you can find a specific value of the c by substitution. So you substitute the value 5, which is x, into the integral. And the value of the integral is 20. So you can find c. Okay. So what do you get? You will get, okay, can you do that? Can you find the, put into the integral. Do not put into the original function because the original function doesn't have a constant. Hari ini saya sesemu sikit lah. Sorry about that. So what do you get? You put x equal to 5, so you got 5 over 4, 5 to the power 4, minus 9 times 5, plus c equal to 20. Therefore, you can get c. What do you get for c? So you substitute, okay, substitute x equal to 5 into f of x. So you get 20 equal to 5 over 4, 5 to the power of 4 minus 9 times 5. Okay, plus c. Okay, what do you get for c? Anybody? Five to the power 4, 100, right? 100. 5 to the power 4, 100, 125, 25 times 5. 5 to the power 4. Okay, anybody? Anybody who get the answer yet? Huh?
36.81.
36.81. Okay, anybody get a different value? Everybody got same? All right. So that is the value of c. So now you got a specific value of c. Okay, specific value of c. So that is what you call, you want to find the c given an initial condition. So that initial condition can be any point. Okay, it can be 0, say 0, whatever, 10, but it's only one point. It can be at x equal to 0, or it can be at x equal to 5. So as long as there is one point, you can substitute. And then what we do normally, after you have the specific value of c, so therefore our integral now becomes what? Becomes 5 over 4, x to the power 4 minus 9x plus And the value is 36.81. So you got now the specific value of C. So you can find, all right? You can find F at any X. So if you're based on that thing, you can find X, what is the function? What is the value of the function? And X equal to 100 or, 50. So we can find, okay? We can find the value of F at any X. Okay, so that is initial condition. Okay, so that is the last part of the chapter 12.1, 12.2, 12.3. So now we are going to do the application. So for application, we go back to 12.1. We start with 12.1 and then we move up to the subsequent parts. So if you look at 12.1, the first application given is the example number 7. Okay, so 12.1, you got the and then to 12.2, basically same application. Just we apply different rules. Then we go to 12.4. So basically application is 12.1 and 12.4. Right? Now, if you look at 12.1 or 12.4, the application is basically based on antiderivative. So the concept is the concept of antiderivative. That means we know the derivative, then we integrate, we get the function. Okay, plus a constant. So that is the concept. Now in application, if you remember derivative, okay, we will start from derivative. If I integrate the revenue, no, I'm sorry, profit, I'm sorry, revenue, I differentiate revenue. What do I get? What function do you call the derivative of the revenue?
Marginal revenue.
Marginal revenue, okay? So you got MR, that means marginal revenue. And then if you have costs, we differentiate costs, we get marginal costs, okay? So marginal costs. And of course, the marginals are the constant term, the same term that you use. If you differentiate profit, you got marginal profit. Okay, if you differentiate consumption, you got consumption, marginal consumption. So that is the idea. So we ask this the other way around. If we are given the marginal cost, you want to find what? I want to find the cost function. So I can find the cost function by integrating. Or given the marginal revenue, then I can integrate the marginal revenue, I will get revenue. So here, this is the idea. Given any marginal, okay, any marginal, profit, revenue, cost, differentiate or integrate the function, but the marginal, you will get the function. Okay, so what is the function? How should I? So this one is not a good idea. So we go by example. Let's say I know the marginal revenue. So I integrate the marginal revenue, I will get the revenue, right? Plus C. So that is an example. So the concept is the concept of antiderivative. So if you look at example number 7, okay, look at example number 7, you will see that the marginal revenue is given 300 minus 0.2x. And then you read the details, you will see It's the quantity, X is the quantity sold. And then you want to find the revenue from the sale of 1,000. So here the X is technology item. What is it? Motherboards. Okay, it's motherboard. So X is motherboards, units of motherboards. So if you look at that example 7, it's about the revenue from the sale of motherboards. So you have here X is what? Units of the product, which is motherboard. Okay, and revenue is in dollars. So that is the revenue from the sale of the product. So you are given the marginal revenue as per in the example. Now, how do you get the revenue? How do you get the revenue? I integrate the marginal revenue. Okay, because what you want to find is, I want to find the total revenue function. So to find revenue, all right, I integrate the marginal revenue, R prime dx, or we can use MR, okay? So notation-wise, you can use R prime, you can use MR, it's the same thing. And that is the integral of the function, which is 300 minus 0.2x dx. Okay, here, I would like to remind, because this is a common, not common, it's a minor mistake, but people tend to do, okay? Now, when you are given a function, 300 equal to 0.2x, this is the function that you want to integrate. So you have to put a bracket, okay, for the whole function to indicate that we are integrating the function as per given in the question, okay? And then you put the dx. Now, some people, okay, this is the common mistake. So I want you to note this. There are a few people who just put down 300 minus 0.2x dx without the bracket. Now, that is wrong, okay? Because if you do that, what does it mean? Because you put the integral sign at 300, and then you put dx at 0.2. So what is it? So it doesn't mean anything, okay? So you must have that bracket like this. That's one. Number two, sometimes we miss the dx, just like that, okay? So that is also wrong. So make sure we know the notation, okay? The symbol, because the notation means what it is. If you miss one thing, that means it doesn't mean anything. Okay, so I just want to highlight that thing because there are people who will tend to, commit this simple mistake. Okay, so given the function you want to integrate that, what do I get? SN. Kenapa tu? We've got 300 x minus 0.2 x squared over 2 plus c. Okay, that c is a constant. That c is not cost, where c is the constant. Or you can use k. Okay, some people use k or c, doesn't matter. Okay, okay. So you can also use k, but we just use c, so you see. So that is our revenue. Okay, that's our revenue function. Now, that is for part A. Okay, now part B, I want to find the revenue from the sale of 1,000. So if X, so part B, if X is equal to 1,000, right, then what is revenue? So here, that's where you need the initial condition. All right? You need the initial condition in order for you to find that C. Because otherwise, if you don't use the initial condition, then your revenue will not be a specific value. If you sell 1,000 units, then you have that C, okay? Now we don't want that. You want a specific value of C. So therefore, we need to apply initial condition. So if you are looking at revenue, what is an initial condition that we normally know without, without given? That point is always true for revenue. Okay, what is it for revenue? Okay, it's selama keyword. Okay. So how do you get the initial condition? What is the initial condition for revenue that we know? I think we have been talking about this for the past few chapters. What is the point that is common for any revenue function? What is it?
At zero.
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 You sell zero, you get zero. Okay? That means if I sell zero, your revenue is zero. So that is the common point. So for revenue, sometimes it's not given. Okay? We have know it already. So the initial condition for revenue is you don't sell anything, revenue is nothing. So therefore, initial condition is at x equal to 0, R is 0. So now you can find C. Okay? So to find C, I will substitute the point 0, 0, okay, into R. So what do I get? I get 0 equal to the revenue function, which is what? Which is 300x. So 300, 0 minus 0.10 plus the constant. So therefore, the constant is 0. All right? 0, 0, 0, 0, 0. So 0. So our revenue now, the C becomes 0. So we only have what? X minus 0.1 x squared. So given this thing here, you can find the revenue. Okay, find the revenue when x equal to 1,000.
Bastu, B.
Huh? Yes? Are you talking to me?
So why is it 0.1?
0.1. Because you have what? You go back to the last page where you take the derivative, we integrate 0.2x. What do I get? What do I get? You integrate this term here. 0.2x. What is the integral?
0.1.
0.1. So you have 0.2 over 2 x squared. So 0.2 and 2 becomes 0.1. Okay? Is that right? Is that okay?
All right, okay.
So you have to make sure you have to go to be aware. Okay, look at the terms. All right. Okay. So that is the example for 12.1. So let's look at the question. Okay, I give you a few questions. 12.1, I already given you the questions that I want you to do. And then for the applications, okay, 12.1, you can do a few questions. Do number 42, 43. All right. And then you do number 48, the population growth. Okay, and then maybe another one, 49, the average cost. All right. Now, I would like you to do another question. Okay, this is a practice on the initial condition. So, can you go to question number 11? So 12.1, all right, question number 11. Now, I already asked you to do the question. Maybe some of you did, some of you didn't. I would like you to get the integral, okay, for question number 11. And then I want you to find the C, okay? Find C given, okay? Given x equal to 1, the integral is equal to, say, 25. Okay, so the thing here is I want you to practice, okay, finding that value of C. So do that question number 11. If you have done that question, good. That means you just do the second part. If you haven't done, that means you have to do both parts. Okay, do the integration and then find C by making use of this information. Okay, do it now. Okay, you got the C? I want everybody to get it. So anybody who has not get the value of C, for those who already obtained, what is the value of C? What C did you get? Anybody who has solved the problem, what is C?
22.4.
22.4. Okay, so you should get C 22.4. So that is one of your friend who get 22.4. Now, if you get another value, that means not you are wrong. Probably he is wrong. Okay, so we just go through that. Anybody who has a different value of C? Question number 11. Okay, now if I integrate the function, I have 3 minus x, 3 to the power of 2, 3 over 2 dx. Now what do I get? I get 3x minus, okay, x, 3 over 2 plus 1. So that becomes 3 over 2 plus 1, 5 over 2. Is that right? 5 over 2 divided by 5 over 2 plus c. Okay. So now you have something like x for 5 over 2. You divide by 5 over 2. That will become 2 over 5 x 5 over 2. So flip it, okay? That becomes division. So that will be equal to 3x minus 2 over 5 x 5 over 2 plus c. Betul kan? Betul tak? Then you substitute. I give you x equal to 1. The value of the integral is 25. You substitute into here. Substitute. Then you get the value of c. Okay? All right. So you will get 24. Now, anybody who get a different value than 24.22.4. So if you get a different value, that means we have to redo it. If everybody get 22.4, we assume that is correct. Anybody get different value?
No, sir.
Sama? Huh?
Sama.
Sama, eh? Okay, good. So 22.4. So if you haven't done, you go home, finish it up. So that is 12.1. I give you some questions already. Now we go to 12.4. That part is on application. There are a few more applications that we are going to look at. Okay. So go to 12.4 je lah. Sebab 12.3 tu dia ada E dengan log. So we don't do that. So we go to 12.4. Now we look at 12.4. I'll go to example number 1. Like I said here, it's the concept of antiderivative. So 12.4, example 1, you have here marginal cost. Okay, we are given the marginal cost, and then you want to find the value of, or you want to find the cost function, all right? Where x is the units of the product and cost in dollars. So you are given, okay, the cost function. You want to find cost. Call it C. So what do? You integrate the marginal cost. Then I got the cost. Okay? Cost function. So that would be equal to integration of 3x plus 50 dx. That is the marginal cost given. Plus, or not plus, equal to 3x squared over 2 plus 50x. Now here C is cost. So therefore, we need to change the constant. So now we use K, all right? Where K is the constant. So we use K. Or we can use K all the way, that's fine. Okay, so now you want to find the value of the K. All right, now what is given? What information are we given? We are given the fixed cost is 10,000. So you want to find K, we can use the information given. Fixed cost equals what? Fixed cost is equal to 10,000. So fixed cost equal to 10,000. That is the point where 10,000. Fixed cost means cost that you incur at x equal to 0. That means the cost that we incur even we don't produce any output. Okay, so x equal to 0, the cost is the fixed cost. So now substitute. All right, you substitute into the integral. Substitute x equal to 0, c equal to 10,000 into that c. So here, you know, I didn't write the thing. We should use this. Okay, either you write here, okay, that's the cost, or okay, after you get the integral, you say the cost function c is equal to 3/2x squared plus 50x plus k. Okay, so now you want to find the constant k. So what you do, you substitute. What do I get? I get 10,000, all right, equal to 3/2 0 plus 50 0 plus k. So therefore, k is 10,000. All right. So k equal to 10,000. Now you have the cost function, specific cost function, which is putting back the k into the cost function. So therefore, all right. Therefore, our c will be equal to what? Be equal to 3/2x squared plus 50x plus 10,000. So that is our cost function. Okay. So in other words, you will get that k here. Okay. That k equals to 10,000. You put back into the cost function. So now the c is 10,000. So that is our cost function. All right. So cost function with a specific value of the constant. Okay. All right. Any question about this? So that is cost. Example number 2. Example number 2, you are also given the cost function. But here, after you have found the k, all right, the value of the k, we will want to find the cost given a certain output level. So, you know, that example number 2. Example number 2, I think we can do that. Example number 2. Okay, anyhow, we can do that also for this example. So now, let's say I want to find the cost of producing 550 units of output. So what do we do? How can I find the cost of producing 550 units of output? What do we do? Substitute into where?
Into x.
Bukan X.
Cost function.
Huh? It's not substitute into X. You substitute X into what?
Into C.
No, into C. X is this one. Okay? So what you do, you substitute X equal to 550 into the C, which is that one. So you get the cost of producing 550. Or for that matter, you can find any output level, what is the cost. So you can say at X equal to 98, then you get the C. Or, you know, X equal to 1,000, you also can get this. Okay? So once you have found the constant here, all right, you can find the value of the function at any point. So look at example number 2. Okay, example number 2, the difference here is just the function, okay? The function is the function you have to use the general power rule. In other words, you need to multiply by a ratio of constant. Now, I don't want to do that example. I would like you to read at home. I just want to look at the integral. Okay, how do I get the integral of that function? So here, I am integrating, okay, given the function, the marginal cost, dx, of course, that is equal to the cost, that is equal to what? That is equal to, given, okay, given 3 2x plus 25 to the power of half dx. So here you have to apply the rule, u prime dx. Then only you can apply the rule u to the power of n plus 1 divided by n plus 1. Okay, now I want you to do this function. Let u be the terms in the bracket, and what do you multiply with, okay, in order to get that u prime. Okay, do it now. This is just practice of what we were learning last week. Okay, I give you a few minutes to do that. All right, okay. Now what is u prime?
2.
2, okay, u prime is 2. You let the terms in the bracket become u. So u is equal to 2x plus 25. And then you get u prime. U prime is 2. Now you don't have 2, you have 3. So what do? You multiply by what?
2/2.
You multiply by 2/2, okay? So if you look at that example, you multiply by 2/2, you bring the 3 outside of the integral, you multiply by 2/2, and then you bring the denominator, 1/2, outside as well. So what you have left is 2, which is u prime. So therefore, you have that form, then you can do the integration. So the integral will be what? Will be 3/2 multiplied by u. Okay, now increase the power by 1, so that becomes 3/2 divided by 3/2, and then simplify. Okay, so you will let u be equal to 2x plus 5. And then you know that u prime is equal to 2, all right? But what we have, okay, we have 3, which is not the u prime, which is equal to 2. So what do? You multiply by 2/2, okay? So that's why if you look at the solution in the book, they will keep the numerator as u prime, 2, and then 1/2, which is the denominator, they'll bring out of the integration with the 3. So you get 3/2. Okay, all right. So I think I will stop here. So you can proceed. And then you find the value of k, okay, the value of k, and then you will do you find the cost of producing 300 units, okay? So once you got the C, okay, now if you look at this question, the k, okay, the k, which is the constant in that function, is not necessarily the cost, the fixed cost, all right? So don't just assume that the fixed cost is equal to the k. Of course, in the first example, that was correct. But in the second example, if you look at the second example, what is the fixed cost? What is the fixed cost given? Example number 2. Anybody has a
1,125.
1,125. Now, what is the value of K?
11,000.
11,000. Okay, so that's why you need to substitute in, because that value of K is not necessarily the fixed cost, because that will depend on the function itself. Okay, so as we can see here, they give you 2 examples. Number 1, a simple example, or the example number 1, you get K will just be equal to the fixed cost. But in the second example, it is not. So what we need is actually, we really need the substitution. We don't just say that given the fixed cost equal to something, then we assume the K is that fixed cost, which is not necessarily true. Okay, all right, good. So that is example number 2. Okay, so example number 2, and then we look at the profit. No, don't worry about the profit. They give you the revenue. Don't worry about the example 3, example 4. Okay, now we go to example number 5. All right, look at example number 5. Now, example number 5 is macroeconomics. You are given the marginal propensity to consume. So you have a consumption function. All right, consumption function. Consumption function here. This is macroeconomics, C. Okay, consumption function C. And the derivative of the consumption function, and the consumption function is a function of y. Oh, y? No, that y is not xy. That y is the independent variable. So function is a consumption is a function of y. C is the consumption in terms of RM, or here dollars, and y is what? Y is the income. All right. Y is the disposable income. Now, income is income. Income is how much you earn for a given period of time. Disposable income is the income after tax. Okay, after you pay your taxes to the government, you have the net income, something like net income. You subtract already the tax or your loan, your whatever debt you have, all right? After tax or after payment of debt. So what you get will be disposable income. That means the income that you have available to spend. So consumption is a function of disposable income. And that is indicated by Y. So that Y is, again here, is a function or is just dollars or RM. Okay? So that is consumption function. Now, if I differentiate consumption function, I got C prime, that means dC dy. What do we call it? We call it the MPC. Okay, what is MPC? It's the marginal propensity to consume. It's just like marginal consumption, but they want to make it more sedap bunyi, okay? Sound good, marginal propensity to consume. What we are doing here is, if I am given the C prime, or the marginal propensity to consume, which is MPC, how can I find the consumption? Again here, you integrate, okay? This is the entire derivative. So you want to find consumption, I integrate C prime Y dy or integrate dc dy, then I get the consumption function. Of course, plus the k. But sometimes, you know, you don't need the k because the k will be built in, right? So we just put here consumption. So that is our consumption function. So if you look at that example, you are given, okay, the MPC is equal to 0.3 multiplied by, or not multiplied, plus 0.4, okay, divided by y to the power of a half. So you bring that up, that becomes negative half dx. So again here, the MPC is the whole function. So you put a bracket for the two terms. So 0.3 plus 0.4 y to the power of negative half dx. Now what is it equal to? That is equal to 0.3y plus 0.4, increase the power by 1. So you got what? You got negative half plus 1. So that becomes a half divided by half. Okay? So divided by half, that becomes multiplication of 2. So you got 0.8. So that will be 0.3y plus 0.4 times 2, that becomes 0.8 y to the power of half plus the k. Okay, here should be k also. Right? So you have the constant k, and then you can find the k. Right? Given, given the initial condition. So you are given a point where when income is 0, the consumption is $6 trillion. So no income, consumption, $6 trillion. So you use that information to find the value of k. Okay. So you are given here at y equal to 0, c is equal to 6 trillion. So the consumption here is actually in dollars, trillion. Okay, not just in dollars, trillion. So trillion of dollars. So you put into the function, okay, then you get k. All right, okay. So that is 12.4. Okay, that example 5, more of macroeconomics. Now I want you to read example number 6. Okay, read example number 6, related to example number 5. Just now, but now you have the savings. So I give you some questions on 12.4. So 12.4, I will give you a few questions that be okay. Try question number 1. Okay, number 1, marginal cost. And number 2 up to number 5, all are marginal costs. So you can do a few, maybe 1 and 6. Okay, in between you can also do, and then you do the question number 12. That is the average cost. I'll give you 1, 6. Right? And then I give you question 12, the average cost. Okay, apa lagi? Average cost, marginal revenue. Mana ada marginal revenue? Oh, marginal revenue tadi tak ada, 12.1. Okay, so marginal revenue is 12.1. And then you can do number 18, right? Number 18 on the consumption, the MPC. So 18. Okay, then we do it. Oh yeah, savings. Savings to do number 24. Okay, so this one 18 and 24 to related. Okay, So that will do it for chapter number 12. Now, 12.5, we don't have to do, okay? We don't do 12.5, we don't do the differential equation. Then that will do it for chapter number 12. Now, any question or any comment for chapter 12? So we are done with chapter number 12. Oke, ada apa lagi? Aduh. Oke, tak ada ya? Alright, tak ada. Okay, good. Now, we'll go to chapter 13. Now, chapter 13 is an extension of chapter 12. Chapter 13 is about definite integral. The definite integral meaning we will integrate the function from one point to another. So in other words, when you do the integration, you just consider the value of x. So it's the integration between one value of x to another value of x. So that is called the definite integral. Okay, so I want you to read. Nih, read. 12.1 tu tak payah fikir. You go to 12.2, all right? 13.2, I'm sorry, 13.2. 13.2, you read the fundamental theorem of calculus. Dia ada satu tu, fundamental calculus. Okay, baca tu je. So that will be the basis of definite integral. Okay, kejap lagi saya datang balik. Baca yang tu tu. Theorem. Okay, now let's continue with the concept. Okay, you got the idea? That is the idea. Itu dia idea dia. Okay, I will just write down what we have here. Now you consider a function, right? Consider a function y equal to f of x. And then look at an interval. Okay, an interval between x equal to a and x equal to b, and b is bigger than a. And we, for now, we just assume a and b to positive. All right. So you have an interval from a to b. So x equal to a, x equal to b. If you look at the number line, this is 0. All right. So we just consider x positive. So x equal to a, and then x equal to b. b is bigger than a. All right. For example, this is 1, that is 10. It can be like that. And of course, that will correspond to a point. So when x equal to a, y will equal to something. All right. And then when x equal to b, y will also equal to something. This one we know. But to do the integration, we just focus on the value of the x. Because the integration, okay, the value of the y is the one that we are going to do the integration. All right? Of course, you can find the value of y though. Okay, so what is the integral? Then the definite integral of the function on this interval is equal to what? Okay, equal to, then we call it, consider a function y equal to f of x, and an interval between x equal to a and x equal to b, b bigger than a, and we denote the interval a, b. Then definite integral f. Okay, definite integral f. We call it, just call it f of x. Let's call it f. F. Let me see, what do they call it? They don't call it anything. So then f is equal to, okay, then f equal to the integral of f of x dx. Now, when you talk about definite integral, we are integrating this in the interval from point A to point B. So this is called x0, and this is x1. And that is equal to, okay, x0 is the first point, so that is A, that's B, fx dx. And what is it equal to? That is equal to f of x plus c, okay, the constant c. And evaluate, okay, evaluated at point A, point B. So we evaluate the value of the integral at A, to evaluate the value of the integral at B. Now, what is it equal to? Okay, how do you evaluate? You take the difference. So that will be equal to f at B plus c. Take away the value of the integral at the first point plus c. And then you can find that c will be cancelled out. C cancel out. So what I have is the value of the capital B, capital F at B, minus the value of the integral at A. So don't worry about the constant, okay? Because at the end, the constant will cancel out. So that is the definite integral. So you got the specific value, F. So you take the difference, FB, FA, you got a specific value, okay, F. Okay, all right. Now, what is it? Actually, this thing here is, now this is actually the following. It's the area. Okay, it's the area under the function y equal to f of x between x equal to a, x equal to b. Okay, so that f here is a number. And that number is what? It's the area under the function between the 2 points in the interval. So graphically, we can show it by this thing. Let's look at it graphically. So you got x, y, and then let's say that is f of x. Y equal to f of x. And that is 0. Now we are talking about positive value. No, don't worry about the negative value. Suppose I have that x equal to a. So that is x0. Okay, a. And then you got b, call it, that's the value x1. Okay, so the definite integral f, like what we were doing here, okay, is equal to the value of the integral at b minus the value of the integral at a. And what is it? What is it? What is this? Okay, this is the area under the function between x equal to a and x equal to b. So we call it that area here. So it's an area, okay? Area, that one is the area, A. And we denote that by F, okay? So sometimes you use F, sometimes we can use just A, because that is the area. So we know now that's the area. We can also denote that thing as equal to A, okay? It's the area between the 2 points, between the 2 values of x equal to a, x equal to b, under the function. So integrate the thing, what I get? I get the area here. Okay, any question? Now, if you have anything, please list up, okay? Because this is a very basic concept. I want everybody to clear. If you don't understand any part, I can repeat. So any question or anything, any comment or any question, whatever, any part that you don't understand, you ask me. I can explain now. Ke semua tidur? Hello?
Understand, sir.
Understand? Everybody understand? Okay, good. I
Yes.
like it.
Yes.
So jangan cakap understand sekarang. Bila buat soalan tak boleh. You know, that's the thing. People say, I understand. But when ask question, you cannot do. Not you lah. You know, there are people. So if you don't understand, there are 100 more people here, more than 100 people here. Anybody who don't understand, those people who never speak in the class, if you don't understand now anything, please raise up. All right? Because I know there are only a few people who keep on talking. Good. You know, I like those people who talk. You know, they make the class at least, you know, some noise so that I can hear some sound. But there are many more people who just keep quiet. So for those people who are normally quiet, okay, I know your name, but I don't know who you are. If you have anything that you don't understand on this part, please raise it up. Anything? Okay, good. So the integral, okay, integral, the definite integral is the integral of the function between the 2 points. So you evaluate the integral at b, evaluate the value of the integral at a, you subtract, that you will get the definite integral. And that will be what? Will be a value. And that is the area under the curve. Okay, f of x between point x equal to a to x equal to b. So basically AB itu interval lah. Alright, so that is the interval. Interval from A to B. Okay, all right. So now, based on this, everybody understand? That's good. I give you one question. Okay, I want everybody to do it. I want everybody to get. I want everybody to get the answer. Okay, I have 10 more minutes. So let's consider an example. Now I want you to find, okay, find the definite integral of y equal to f of x equal to x squared plus 3 from x equal to 2 to x equal to 6. So in other words, all right, the interval AB, okay, is equal to 2, 6. Okay, this is what I want you to do first. Just follow what I ask you. Number one, I want you to sketch the function on a graph so that you know how the curve look like. Sketch, okay, don't draw. I just want to see the shape of the curve, and then that's it. And then you denote a point, x equal to 2, x equal to 6. And then we know that would be the area that we want to find. So in other words, you go draw this graph, not draw, sketch. Okay? This is a general graph. I want you to be specific. I want you to sketch the graph of the line x squared equal x squared plus 3. So if you don't know, you ask your friend or you ask me. Okay? So you can use derivative. Go back and use derivative. You know, you do the second derivative test, you can do this very quickly. All right? Okay, do it now. Get the graph first. Sketch. Okay. You got it? Okay, Amir Mukhlis. How does the curve look like? Okay. What is the y-intercept of that line, of the curve? What is the y-intercept?
Tiga.
Huh?
3.
3. Okay, how does the curve look like? Okay, this curve, does it have a maximum or does it have a minimum?
Minimum.
Minimum. Okay, so the curve has a minimum. There is only one minimum. And that curve will go upward. All right, go upward. What is the minimum point? 3, yeah. 3, 0, 0, 3. Is it 0, 3?
0, 3.
0, 3, yeah? So if you already do, you know, the test, you will get the graph will look something like this. This is y, x, y. Quadratic function macam tu je. Alright, quadratic function x squared. They are the minimum, so that is x squared plus 3 equal to y. So, okay, so you just need to sketch so that you know how the curve look like generally. It is not a linear function, it will be like this. We need the interval x equal to 2 up to x equal to 6. And of course, you can find the value y. Okay, but you don't need that. Okay, for this definite integral, we don't need that value of y. We need x. So the interval is from 2 equal to 6. And the definite integral would be the area between 2 and 6 under the function. So that is the area. Or, you know, I use f, but now we can use just a. So that is the a. All right. So this is the thing that you need to find. So find the integral, okay, of the function from x equal to 2 to x equal to 6. So intuitively, we know this is what we are going to find. Okay, intuitively, we know, all right? We already can picture that thing. So now you use the formula, okay? Use the formula, get the integral. So apply the formula here. I want you to do it now. Okay, apply the formula. I want you to do it up to here. Up to that, up to sini je lah dulu. Okay? So now we know the C we cancel out, so you don't need that C. Okay? That C you don't need. You just get the integral of the X. C itu tak payah dah. Okay? So can you find the integral? So if I do that, then kita benda ni jelas tinggal. Okay? F of X. FC. So you follow the formula. All right? So the integral is from where to where? The integral is from A to B. Now what is A now? 2. What is B? 6. So you put 2 at the bottom, B on the top. And then the function is x squared plus 3. Okay? Put a bracket, integrate. So now what do you get? Anybody who get the integral? Just like, tell me the integral. Mana dia function tadi? Okay, function tu is x squared plus 3. So, the integral, which you can call it f, or you can call it a, equal to the integral of what? The integral from 2 to 6 of x squared plus 3 dx. And we know how to do it. Yeah. So what is the integral? Just give me the integral of x squared plus 3. What do I get?
X
Power of 3 over
X cubed
X cubed over 3
3x.
plus 3x.
plus
Now you
3x.
don't need the constant. Okay? So we just stop there. And then we integrate from 2 to 6. Now, how do I get the value? You evaluate the integral at b. Okay? You go back to the formula. You evaluate the integral, you evaluate integral at b. Okay? And then subtract the value of the integral at a. Subtract. Okay? Then you will get a number. So let's do it. Okay? So I want you to try. Do that. Evaluate the function here at 6. Okay? Minus. You evaluate the function at 2. Don't break up the bracket yet. Okay? You keep the brackets. And then only we break up the bracket. So that is equal to what? That is equal to, we evaluate the value of the function at 6. So 6 to the power of 3 divided by 3 plus 3 times 6. So you got one value. And then take away 2 to the power of 3 over 3 plus 3 times 2. So now you get, I don't think you can simplify anything. So just do it. Apa nama? Evaluate that thing. Evaluate benda ni. Take away. Okay. Siapa ada calculator? If you have calculator, what do you get for 6 cube over 3 plus 3 times 6? What do we get?
90.
90.
90.
Okay, 19. Sini 19. Take away. What is the value kat sini?
90, sir.
90, sir.
90.
0.
Okay, 90. Saya dengar macam 19 ni. Okay, 90. Tolak berapa? 8 bagi 3.
8.67.
8.67.
8.67. So you will get the difference, Then you will get the value 81.33. 33. Kita ni menolak slow lah. Calculator tak ada. 33. Okay, thank you. So that is the definite integral. So you get a value. Okay, it's definite. Definite means it's a specific. So therefore, the area here is equal to the value that I have. By getting or by evaluating the integral from 2 to 6 of that function. So it's 81.33. Okay, of course, the unit of area is unit square. Okay, unit square lah, kan? Unit square, area. Tapi tak payah sebut, tak apalah. Alright. So the area is 81.33. Okay. Alright. So that is definite integral 13.2. So I would like you to read, okay? I give you only one example. You can go ahead and read a few more examples, examples number 1 and 2, these are good examples. And then I give you a few more questions to do just for your practice. And then on next week, we will continue from here. You can try question number 2, and then number 6. And then you can just do the positive ones. You don't have to worry about the negative. Do number 12. Okay. So then next week we're going to continue from there. All right. Okay. Have a nice weekend. Take care of yourself. Nowadays, the COVID-19 cases is still increasing. Yesterday we have 2,000. Before that 1,000 plus. Yesterday 2,000. So therefore, we still need to take care. All right. Even though I think there is freedom of movement, but we have to be careful. Okay. Follow the SOP. So I will see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, Gusar.
Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Okay, thank you.